Welcome back to episode number 2 on the Basic Mathematics series. We recently saw how additions have certain rules and properties. In this video, I'm going to go over multiplications, and we will find out that they have a lot of similarities as well as some particularities. Okay, the first similarity we find between additions and multiplications is that they both are associative. To recap, this means that a times b is equal to b times a. And they are also commutative. This means that if we have something like b times a times c, we can express it also as a times b times c. One extra properties that multiplication have is that they are distributive. What this means is that if we have something like b plus c times a, we can also express this as a times b plus a times c. Other rule that we have to be aware of is the multiplication by 1, which is that 1 times a is a, and by 0 times a is 0. We can use associativity and commutativity to prove distributive property, right? Distributive property states, as we just saw, b plus c times a is b a plus c a, for example, right? And this is just a way of expressing it, right? We could also have it like a times b plus c, reordering a little bit, and this is by the associative property, right? We could have a times b plus a times c, which is the same thing, and this is equivalent to ba plus ac. It is important to state that all of these rules apply for positive and negative integers. But we know that two negatives, so for example, minus 1 times minus 1, is one positive, right? This is also something that we can see by ourselves just by distributing better the elements. So if we had something like minus a minus b, this is equivalent of saying minus times a times minus b, right? It is exactly the same thing. And we could also express it like minus a minus b, or even we could express it as minus ab, right? And this is ab, right? Because this would be negative. If you wanted to say it with numbers, this is the same as saying minus 3 times minus 5. This we can express it as minus 3 times minus 5. And this is equivalent of saying minus 3 times 5. We can use the dot to express multiplications as well. And you see this is basically minus 15. And this is equivalent of saying minus 15. And this is 15. I hope this is clear enough. When we talk about powers, what we're saying is basically a number or an element multiplied by itself, right? So a times a, we say this is to the power or the second power, right? There's two elements, so this will be a to the second. We say to the nth power, right? This is an n. I'm sorry for my handwriting, but this is an n. If we had a times a, this is a to the third. If we have a times a times a times a, this is a to the fourth. And if we have a n times, this is a to the n. When we have something like a to the second, for example, times a to the third, this is equivalent of saying a to the 2 plus 3, or a to the fifth. This can be expressed as a to the m, for example, a to the m times a to the n. This is equivalent saying a to the m plus n. If we have something like a to the third times a to the fourth, we just saw that what this means is a multiplied by itself 3 times. A times a times a, right? And we're multiplying this by a multiplied by itself 4 times a times a times a times a, right? So by the rules that we've seen in multiplications, we can also express this as a times a times a times a times a times a times a, and this is 4 and 3, right? So we can express this as a to the 7th, right? Or a to the 3 plus 4. When we have something like a to the n times b to the n, we then have a to the n, b to the n. And you can see the relation here, right? Because if we have a to the n times b to the n, this would be something like a, b, and so many times, right? To the n. If we then use associativity rule, we would have all of our a's on one side, all of our b's on the other side. We would have something like this, and this we will have n a's, and here we will have n b's. So you see a to the n, b to the n. So to finish off, I would like to make a simple exercise where we can see how we can use these rules to solve simple problems, right? So the exercise states that the population of a city grows twice as big each 10 years, for example, right? And currently it is sitting at 20k. Each 2 years, this grows. Each 10 years, this grows double. So 10 years, in 10 years, it would be 20k times 2, right? What if we wanted to know how big this city would be in 80 years? Well, this is something that we can use powers, right? So in 10 years, it would be 2 times 20k, right? In 20 years, it would be 2 times 2, 20k, right? In 30 years, it would be 2 times 2 times 2 times 20, right? And so on until we get to 80 years. So this is equivalent of saying, this is equivalent of saying 2 to the 2, right, times 20. This is equivalent to saying 2 to the 3 times 20. So this is equivalent to saying 2 to the 8 times 20. 2 to the 8 times 20, it would be 5180k. And we can, compute this way any sort of time frame that we wanted to know in an example like this. Well, I hope this was helpful and that you learned something new, and see you in the next one.